In this video, we're going to tackle the same problem we tackled in the last video, except this time we're going to use the computational formulas, not the tabular method. Let's see if we get the same result. Let's just start out with a quick review. Our ultimate goal is to compute a value for f. F is made up of the observed variance between the groups and the expected variance. And again, any data set will be characterized by some level of variance, some data sets more than others. So we're going to look to see whether or not our observed variance is in line with our expected variance, or if the observed variance, again, the variance between the different groups, is very different than our expected variance. Mathematically, we're going to calculate a mean square between and a mean square within groups, mean square between groups and mean square within groups. And we're going to calculate that using the sum of squares between divided by k minus 1. And we're going to get the denominator with the sum of squares within divided by n minus k. All right, so you can see we need this mean square between and we need this mean square within. Now, let's recall that the total sum of squares is equal to the sum of squares within plus the sum of squares between. So if we can calculate any of these two elements here, we can always get the third. The computational formulas that we're going to use are as follows. For the total sum of squares, that computational formula is the sum of each of the x values squared minus the total number of values, n, the total number of values in the study, total number of observations in the study, multiplied by the grand mean squared. All right? So let's calculate that first. First thing we need to do is we need to calculate the sum of the x squareds. So to do that, we'll just take this first one over here. We'll square it, and that's our first value. We'll do it with the next. 3 squared is 9, 8 squared is 64, 6 squared is 36, 25, 36, 25, 81, 100, 169, 64, 81. We just make that a little bit easier to read so there's no mistakes in addition later on. And in our third group, group C, we have 64, 36, 144, 121, 121, and 144. And these add up to 1,324. Okay, so now we have the first part. We have this part over here. Now let's work on getting our second term, n times x bar, the grand mean squared. Okay, well, the grand mean, you may recall from the problem in the previous video, the grand mean in this case, x bar g, was equal to 8. So we're going to have n of 18 because there are 1, 2, 3, 4, 5, 6 rows and 3 columns. So we have 18 values. So we're going to have 18 times 8 squared. That's going to give us 1,152. So we have our first term is 1324. That came from down here. Our second term, 1,152. And if you do that subtraction, you're going to get a total sum of squares of 172. The same thing we got in the previous video. So TSS equals 172. All right, let's remember that. And now let's move on to calculating sum of squares between. The sum of squares between problem, the sum of squares between formula is written like this. It is the sum of the number of observations in each group multiplied by the mean for each group. I'm going to call that x sub k minus the grand mean squared. All right. So what do we need for this? Well, we need to calculate these x bar k's. And we did that for the previous problem, so I've just transferred it over here. It's 5, 9, and 10. All right. There are 6 observations times 5 minus the grand mean, which was 8, squared. The next one, we're going to have, again, 6 observations times the mean was 9 for group C minus 8, and we're going to square that. And then the last one, 6 times, that was 10, that mean was 10 minus 8, and we're going to square that. All right. So let's work out the numbers here. That's going to be 6 times 5 minus 3 is negative 3. Square that, we're going to get a 9. 9 minus 8 is 1. Square that, we're going to get a 1. So that's 6 times 1. And this is 6 times 10 minus 8 is 2. Square that, we're going to get a 4. 6 times 4 is 24. We're going to add those all together. And if we add these all together, we get 84 for our within groups sum of squares. I'm sorry, our between groups sum of squares equals 84. And since we know that the total sum of squares equals the within sum of squares plus the between sum of squares, we can easily calculate the within sum of squares, which is going to be 172 minus 84, which equals 88. The same value that we got in the other video when we used the other method of solving the problem. I'm not going to review computing the mean square between or the mean square within, because the numbers are exactly the same as they were. The important thing here is that we see that we can solve these. We can solve for the sum of square between and the sum of square with and the sum of squares within using these formulas. Again, we're going to first solve for the total sum of squares using this formula over here, and then we're going to compute the sum of squares between using this formula over here. And then finally, we use this formula over here to compute the sum of squares within. Okay, well, I'm not sure which approach you would prefer. In some cases where you're not given the artificial situation, where you're not given the data set, you may have to use these computational formulas. If you are given the data set, well, it's up to you to decide which approach you like better. The table method that we learned about in the last video, or using these computational formulas. Again, one of the things I really want you to bear in mind here is that normally these problems are going to be solved using a computer. The formulas are important to know, but much more important to know is what is going on behind the scenes. What's the relationship between the mean square between, MSB, and the mean square within? How do you compute the mean square between and the mean square and the mean square within? What are the appropriate degrees of freedom to use? If you can focus on those things, you're going to be way ahead when it comes to using these techniques on a real data set.